Here I'm going to talk about translations. Another way to think about translations would be a slide. So this again is a transformation, just like reflections. We're going to move points or move figures, and in this one we're going to move them the same distance in the same direction. So I have one little example here. My yellow triangle is the pre-image, my green triangle is the image, and all I'm doing with every single point is I'm sliding them or translating them to the right 8 and down 4. Now it's not just the vertices that would be happening with. I could pick any point in here. I could pick this point right here, and if I were to go 8, 1, 2, 3, 4, 5, 6, 7, and 8, and then go down 4, 1, 2, 3, 4, this point right here would be the image of my blue point. So you can think of it this way. We go blue point to blue point, we have pre-image and image. So it's every single point has been translated to the right 8 and down 4. Now there's a couple different ways to show this mathematically. Oops, didn't want to move that like that. The first is what I refer to as the transformation symbolization. What this is telling you is for every point, call it xy, so I have a point, and what it's telling me is the new coordinate's going to be x plus 8, comma y minus 4. So whatever the x value was, add 8 to it. Whatever the y value was, subtract 4. Now, had I gone, say, to the left 8, then this symbol right here, math symbol, would have been a minus sign, and had I gone, say, up 4, this would have been a positive. So you just got to look at it and realize, well, if I go to the right, I'm going to add. If I go up, I'm going to add. If I go left or down, I'm going to subtract. And then another way to look at it is what's referred to as the coordinate form. And in this one, it kind of looks like an ordered pair as a point. But notice we're not using the parentheses. We're using I call them the arrow parentheses. And all it's going to tell you is every point is moving 8 left, or excuse me, 8 to the right because we have a positive 8, the blue, and 4 down because we have the negative 4. And that's your transformations, or excuse me, translations. I get those confused sometimes. It's a translation, which is a form of a transformation. Now I'm going to look at 2 examples in here. On this first one I have triangle PQR, and it's been translated using the translation, and it gives it to us. We want to find the image, triangle P prime, Q prime, R prime. Now, a couple ways to do it. I'm going to show you the first way with point P. I'm just going to plot point P. It's at -2, 5. So here's P. Now, I look up here at my translation, this right here, and I look into it and see, well, it tells me I'm going to have to go 3 to the right and down 2. So I go 3 to the right, 1, 2, 3, and I go down 2, 1, 2, and then this point right here is my P prime. Now, being I'm on the coordinate grid, I can figure out the location of that. So I go to my origin, go 1 to the right, up 3. That's going to end up at P prime, which we just said is at 1, 3. Now, the other way we can look at it is we can just use what I have in the green here. And I can take, I'm going to go with point Q then, which is at 1, 7. So I'll take my 1, 7, and according to the translation, it tells me that I have to take my x value and add 3 to it, then take my y value and subtract 2 from it. And that will give me the coordinates of my new point, which will be at 4, 5. Now, if I graph these 2 points, 1, 7, so that would have been point Q, and then my, should have done this is Q prime, and my Q prime is at 4, 5, right here. And if I look at that, well, I'm still going 3 right and 2 down. So take your pick on how you want to figure out where R is. It doesn't really matter, but if we start at -3, 1, 1, 2, 3, 1, it's going to end up here. So there's R prime. So when you look at this, we have a pretty skinny triangle here in triangle PQR, and then we're going to have a pretty skinny triangle here in triangle P prime Q prime R prime. And had I used straight edges, you would be able to look at these two triangles and realize that they are congruent. So translations are another form of an isometry. Now my last example here, now on this one I'm giving you the pre-image. I'm giving you the image, and I want to find the coordinate form of the translation. So how far do we have to move left or right? How far do we have to move up and down? I'm going to take my point P that's at 8, 3. I'm going to take my point P prime that's at 2, 7. And what I like to do to start with is I just like to look at this and go, well, if I'm at 8 and I go to 2, well, I've subtracted 6. And if I'm at 3 and I go to 7, I've added 4. Now, what we can do is this. We can take those points and we can essentially subtract them. And what I look at here is, if I take 2 and I subtract 8, well, I'm going to get negative 6. If I take 7 and I subtract 3, I'm going to get a positive 4. So here, in the coordinate form of my translation, it would look like that, negative 6, 4, which tells me move to the left 6 and go up 4. So you can always remember that you need to take the image and subtract the pre-image. And again, if you forget that, that's where I just like to kind of do that visualization where if I start at 8 and I go to 2, what did I do? Well, I moved 6 to the left. So how do I get it there? I'm going to have to subtract image minus pre-image. And that's going to conclude my lesson on the translations.